So now that we've seen sine and cosine, we can talk about the third main graph, which is tangent. And one important thing to remember about tangent, tangent is equal to sine divided by cosine. So if you know the sine of something and you know the cosine, you can find the tangent. So what does that mean about the graph? Well, here's the same procedure we're going to take. We really don't need 5 points. This is slightly different. We're still going to start with what makes the parentheses, or in this case the function, equals 0. So we'll start at 0 degrees. We're still going to increase by the period divided by 4. Okay, but here's the difference. Again, this could be done differently. I think this would be the easiest way to understand it. The period is not 360 this time. The period in the case of tangent is only 180 degrees. And I'll tell you why. If you go back up to the graph on sine and cosine, remember that sine and cosine, they alternated between these values right here. They were always going to be, at least at our main points, they were always going to be zeros or something with 1, either 1 or -1. So here's the problem, and that works for sine, that works for cosine too. You can see the table on the right for cosine. Here's the problem: if tangent is sine over cosine, we just said that those are going back and forth between 0 and 1. So think about this: what would happen if we hit the point where cosine is 0? And let's recall on the unit circle, cosine is 0 on the unit circle. Go way back up here. Cosine is the x-coordinate. The x-coordinate is 0 right here at 90 degrees and also right here at 270 degrees. So cosine is 0 at both of those points, and sine is 0 at 0 degrees and at 180. So let's keep that in mind. I'm going to write that down below. Cosine is 0 at 90 and 270. Okay, so let's just have a note for ourselves right here. Cosine of 90 and cosine of 270, those both equal 0. Okay, and then we said that the sine of 0 and also the sine of 180 are equal to 0. So what that means is, on our graph, when cosine is 0, we're going to be dividing by 0. And what happens at that point is you get something undefined. So let's increase the period divided by 4. Why is it going 180 instead of 360? Because on sine and cosine, we're essentially having to cut the period in half. Important things happen twice as often on the graph of tangent, because not only are you getting the contribution of sine, you're getting the contribution of cosine. So 180 divided by 4 is 45. And we'll graph several of these just so you can see how it looks like. So we'll increase by 45 each time. So that means 90 and 135 and 180. And that's a complete period. Let's do a couple more after that just so we can get a really solid picture. So 225 and then 270, and that's good enough. All right, so the tangent, remember again we said tangent is sine over cosine. So you may have these memorized, or you might use a calculator, or you could just do this by plugging them in. So tan of 0, that's the same as sine of 0 over cosine of 0. Okay, the sine of 0 we said right here, the sine of 0 is 0, so this is going to be 0 over, it turns out that it's 1, but it doesn't really matter. 0 divided by anything is 0. So that means our point 0, 0 is on that graph. Okay, you can see the way this is set up: 60, 120, 180. It looks like every one of these is increasing each time by 30 degrees. So this is 30, this would be 90, this one is 150, and so on, 210, and etc. All right, so then let's get the next one. So the tangent of 45 is the same as sine 45 over cosine 45, and that turns out to be equal to 1. So 45 degrees is maybe about halfway between 30 and 60, definitely halfway between. Tangent of 90 is sine 90 over cosine 90. Now here's where we run into a problem. Cosine of 90 we said is 0, and sine of 90 is 1. So 1 divided by 0, that means it's undefined. What does the graph look like at undefined? It basically has what's called a vertical asymptote. And I'll draw that in blue so you can see it a little bit clearer. Okay, vertical asymptote means when you're dividing a function by 0, you get essentially it can't do that. Okay, so the way that the graph looks in between these vertical asymptotes is it just kind of goes upwards like that. And then on the other side, there's going to be another vertical asymptote down here, and that's why we're about to graph these other ones so we could see it more clearly. All right, so the next point, tan 135, that's like sine 135 over cosine 135, and you can plug that if you wish into a calculator. It turns out to be another version of 1, but this time it's -1, because 135 has a reference angle of 45, which we calculated right here. However, we're in the second quadrant. The second quadrant tangent is negative. Okay, you might remember the phrase, all students take calculus. So this is 135 negative 1, so that puts us right here. And then we have tan 180, which is sine 180 over cosine 180. Sine of 180 is 0. Cosine of 180 doesn't matter what it is, because 0 over anything is 0. So we'll have 180, 0. There's a point right there. 225 is also going to be a reference angle of 45. So sine 225 over cosine 225. But we're in the third quadrant at 225. Tangent is positive in the third quadrant. So 225, 1 would put us right here. And then what happens at 270? This happens. Cosine of 270, we're going to have another undefined, another asymptote, vertical asymptote. So let's draw that in. So we said 270 is in between 240 and 300. We said that the period of tangent happens every 180 degrees. Okay, so we have just shown with this picture, okay, this really all we needed was that middle point right here. We've just shown one complete period. This green distance right here, that's one period of tangent, or 180 degrees, because we're going from 90 degrees right there to let me label that 270 right here. And to show one period, it's a good idea to show the two vertical asymptotes that are bounding it, and then in between, the graph of tangent always looks like this. So if you were to draw another point right here, it would be, let me just think about where this would be. This would be the next asymptote would be another 180 degrees. So at 450, it's actually going to get cut off. But basically, it would look like this. Every time, it's going to go in cycles where you have that red line going up forever on the right, down forever on the left, and then bounded by vertical asymptotes on both sides. So that is what's called the parent function for tangent.